Okay, so let me tell you about frequency of compounding. So far, we have assumed that interest rate is an annual rate, and I've given you problems that talk about 2 years, 3 years, where 5 years, whatever, and the interest rate is an annual interest rate. Now, it doesn't have to be that. In fact, in a lot of examples, interest rate is compounded more frequently. It's more than annual, more frequent than annual compounding. So, for example, in mortgage loan situations, for example, when you calculate your monthly payments, it's typically on a month to month basis, which means that typically compounding occurs monthly. There could be daily compounding where you borrow money from a bank, which is interest rate, which is compounded daily. So there is all these different frequency of compounding that you need to pay attention to. You cannot always assume annual compounding. In fact, when you have more frequent compounding, that means money is growing faster. So that's the first thing. There's a direct correlation between frequency of compounding and how fast money is going to be growing. So you need to pay attention to that. So here is an example that illustrates frequency of compounding. You deposit $1,000 into an account that pays 12% interest compounded quarterly. How much will be in the account after 8 years? So on the face of it, this is a lot like or almost like the problems that we have discussed so far in earlier video segments, with one important difference. And that difference is that we throw in that little phrase there, compounded quarterly. So it's a 12% annual rate compounded quarterly. So there are a couple of things to keep in mind. The period that we've talked about so far, in the simple examples we have seen, because they were effectively annual compounding and we were looking at number of years, 2 years, 3 years, the n was relatively simple to calculate. They were just exactly whatever the number of years suggested. It was 2-year problem, 5-year problem, n was 2 or 5 or whatever. Here, you have to pay a little bit more attention to accurately adjust two things. One is, what is the effective interest rate per period, and what are the number of effective periods involved in the problem? What are the effective number of time periods, and what is the corresponding interest rate per period? Now, what do I mean by that? So let's break down this problem. So it is 12% compounded quarterly, and there are 8 years involved. But 8 years when you do quarterly compounding, that means that every year has 4 periods. Okay, keep that in mind. Pay attention. This is the important part here, that n equals 4 per period, which means when you're dealing with 8 years, the equivalent number of periods is 8 times 4, which is 32. So n is no longer 8 in this problem, but n is 32 quarterly periods, right? That's the first thing to keep in mind. Now, the next part of what I just told you is, what is the effective interest rate per period? Remember, the period now is a quarter, 3 months. So if you have a problem that says 12% interest compounded quarterly, that means the effective interest rate per quarter is 12% divided by 4, which is 3% or 0.03. So those are the two things you need to now adjust and pay attention to. So in the revised version of this problem, now that we've decoded all this, is interest rate will be 3% per period, and the n is actually 32. 4 times 8, 32. Everything else remains the same. Your present value is $1,000. What will be the future value? So putting into our well-known formula that you should be totally comfortable with, the future value is then equal to the present value, which is $1,000, times 1 plus I, which is 0.03 or 3%, raised to the power n equals 32, 4 times 8. And if you do all that, then your future value will turn out to be, and again, I hope my math is correct here, it's $2,575.08. that'll be your future value. Now, if you are interested and you're really, interested in this topic, you can try this out with annual compounding. You can solve the problem, same problem with annual compounding, in which case your I will be 12% or 0.12 and N will be 8, and you'll see what that future value is. Your present value is going to be same as always, $1,000. And you will see, and you can verify this for yourself, is that the future value would be less than what you've gotten here. The 2575 and '08, that is greater now. And when you reduce the problem to its annual compounding version, the future value will be smaller. The future value would be smaller than what you have here. And that just makes the point that I tried to make earlier, that it is the frequency of compounding makes money grow faster. So keep that in mind. And I'm going to also briefly touch on another problem for you to practice these ideas on. And you can select the correct answer from this list given to you. But try it out on your own to make sure that you truly understand the ideas that we have discussed.